Bread. Our daily bread, which many people take for granted, requires quality wheat, economically produced, marketed, transported, milled, and baked. Over 300 million bushels of hard red winter wheat per year are produced in Kansas. Kansas has for a number of years enjoyed the reputation of producing quality wheat for making good bread. Concern for maintaining quality wheat in Kansas and the market for this wheat is the reason for the Kansas Wheat Harvest on-site protein preview. A hand-carved bread plate was a symbolic wedding gift of a generation ago. But since that time, production of bread and the grain industry have changed considerably. This modern industry is no longer local, but worldwide. Nutritional studies have indicated that bread alone can supply the major portion of protein and carbohydrate needed for body growth, maintenance, and energy. Not all wheat is bread quality wheat. Some of it is the wrong type. Durum is used for pasta products. Soft wheat is used for cake, cookies, and crackers. Kansas is one place where the conditions are suitable for growing hard red winter wheat. The customers for this bread quality wheat are domestic flour mills, as well as government importing agencies from other countries who do not have a sufficient quantity of this quality wheat. The miller in the United States contracts to supply bakeries flour which has a very definite specifications. As we look at planet Earth from a satellite, we observe North America. The wheat growing area in the United States is in the Great Plains. On a line in this area, we go from Wellington to Hutchinson to Great Bend to Hayes. Many samples from neighboring areas were brought in to each of these various locations. In this way, a representative portion of the wheat belt of Kansas was covered. This handbill was used to advertise this project. A team of 5 people are commonly involved in the buying of grain. This teamwork approach is essential. Dominance of the economy by the grain industry in the Great Plains, particularly Kansas, the wheat state, is in evidence by the size and number of grain elevators. These elevators, which dot the landscape, are serviced by railroads for transportation of the grain from the country elevator to terminal elevators, and from terminal elevators to flour mills or to ports. In Hutchinson, Kansas, in the heart of the wheat country, is located a number of large elevators. Transportation is essential in this industry. The elevator that you see here is the longest in the world, just a few short feet of being a half a mile long. Notice the railroad cars down below this immense facility. Similar facilities in the immediate area bring the storage capacity to over 36 million bushels, or 992,000 metric tons. The dollar value of these crops is large. The total capacity in the Hutchinson area, if devoted to wheat, would be sufficient to produce 2 billion loaves of bread. We have established that the grain industry is indeed a mammoth industry. Equipment involves a great investment on the part of the producers. A 20-foot cutter bar is common in western Kansas. Here is a scene at harvest time, which is very common. What we have is overflowing, therefore we have plenty to export. In the ports, such as Houston, and on the West Coast, a great deal of grain can move about. 45% of the exports in the world were dominated by the United States in the past few years. This means efficient farming enables us to have a bountiful crop, plenty left over to export. Breeding plots at the Kansas Agricultural Experiment Station farm at Fort Hays are used for the improvement of wheat. Early generations of these samples are milled on an experimental mill at Kansas State University in the Department of Grain Science and Industry. This very small mill has all the functions of a large one, but in miniature. Here we see the full-scale pilot mill at Kansas State. Observe the wheat going over the first break roll, where the hull is separated, broken apart, and the endosperm can be taken out. Here we see the fractions after milling. This is only the first step in milling, however. It's an extensive process. A pneumatic transfer system takes the mill stock from one level to another. As it gets to the upper level, gravity is used to bring it down through the various processes. At the uppermost level, the solid material is separated from the air, which is used to propel it to the top. The level just below this, where the miller is getting off, is the floor where the sifters are. The sifters are in a rapid motion, and below the sifters we can observe different streams, and the composition of these streams will be markedly different. Here we observe a rather coarse material. Here is the rather fine material. So we have the hulls and something that is beginning to look like flour coming off of the sifter after the first stage of milling. This process is repeated over and over again. Bran, flour, and wheat germ are some of the products of the milling process. At this pilot mill, a rather unique facility, large-scale milling tests are conducted on later generation breeding samples prior to their release for growers of certified seed. By keeping a close control, only improved varieties are released for growing. Not only Kansas developed products come here, but those developed at the agricultural experiment stations in other states and by private growers are evaluated here. We see after the flour has been milled, it goes through the sack off, where it is then sewn up and ready to be loaded out. Part of the evaluation of wheat for its ability to be made into bread is the physical dough testing. We see here the bowl of the farina graph. The dough is stretched and pulled, and the tension is measured and plotted on a graph. This particular farina graph is of good quality wheat. Let us visit the protein testing site. This farmer has heard about the free test on a local radio station, where he has also been reminded about the importance of obtaining a representative sample. It was suggested that he do this by collecting a little bit at various times during transfer from the hopper to the bin. Mixing this in a 5-gallon container and taking a subsample sufficient to fill a 1-pound coffee can. For each sample, the customer provides information regarding the variety, yield, location and size of the field, and information about the fertilizer used. It is essential to remove the foreign material, such as chaff and broken kernels, by simple sieving. The sample size is reduced by putting it through a divider. Hopefully, a representative sample remains, but yet one of smaller quantity. It is then necessary to grind this in a miniature mill. This particular mill provides particles, 50% of which will pass through a 150 micron sieve. This is essential to use the infrared reflectance technique of protein analysis. We also want to make sure the sample is homogeneous, so it is stirred up. After it's placed into a sample jar, it's given back to the customer, who then proceeds into the van where the infralyzer, that is the infrared protein tester, is operating. Further stirring assures a homogeneous sample. The principle involved here with this system is that the protein molecules all contain a nitrogen-hydrogen group. As the nitrogen-hydrogen bends, energy is subtracted from the beam of radiation. The more energy that's subtracted from the beam of radiation, the more protein is present in the sample. This is a spectroscopic method of analysis as opposed to a chemical method. We must have an optical surface to present to the beam of radiation. The main advantage of this method is speed and convenience. The optical system involved here has a radiation coming from a lamp through a lens and going through filters. We have 6 filters from which 6 wavelengths can be selected continuously. Some of these wavelengths are specific for protein, some for moisture, some for other materials. The radiation which bounces off the sample hits the detector. 14.2% protein represents high protein wheat. This not only would make good quality flour, but could be used for blending with inferior wheat to bring it up to a suitable level. It is important to report the protein on a common moisture basis. So we've calibrated this instrument for moisture as well, and we find that this, after switching to that channel, 10.1% value of moisture is used to calculate the protein on a common moisture basis. In this way we can get a good comparison between samples of a different moisture. On the ticket is reported this information so that the customer can assess his agricultural practices for the past year, his use of fertilizer. He will probably consider this when selecting seed for the coming year, and perhaps consider this in his marketing plans. The decision as to what wheat to save for seed, which to store on the farm, and which to take into the elevator and sell may depend on this protein content. Rapid analysis at the harvest site prior to dumping and mixing could make it possible for such wheat to be marketed with its identity preserved. Then both the producer and the grain handler could cash in on the domestic and foreign blending wheat market. Storage and transportation facilities and a suitable price differential are necessary factors. Over 1,900 samples were analyzed on this program, and differences between fields, various seeds, crop years were noted. A running double check was done with every day's samples by infrared. These were sent to the laboratory at Kansas State for a Keldol analysis. This analysis is the wet method involving acid put in with the sample. The next process is digestion, in which the protein is converted to ammonium sulfate and other salts.